Hello everyone, welcome to my YouTube channel. I am Malik and I am back with another video. In this presentation, I want to demonstrate how to set up a CI/CD pipeline using GitLab. In this pipeline, I have designed a web page module and I will show you how to deploy it as a microservices container on a Kubernetes cluster by GitLab CI/CD. As you know, in these days, most of the applications are built based on microservices, not monolithic. So each part of application are done by a separate team. Here we assume we were asked to design a login part of application, this one, and we need to test it on Kubernetes cluster. As you see, it is on my local computer. Also, here is the HTML source code of this application. We need to test it on Kubernetes cluster before deliver it and see if it properly works. And at the end of this presentation, with entering the IP address of Kubernetes node and access to this login page. So, as a designer, I designed this HTML page and it is ready to test it on Kubernetes cluster. So, the source code here is on my computer. So, I need to build a container image from the data that I have and push it on container registry. Then on Kubernetes cluster, by running proper manifest, pull image from the container registry and bring up the container here. So we want to do all these steps by using GitLab CI/CD. Okay, let's start. For running this presentation, we need to have a GitLab account. It doesn't matter if you are using gitlab.com or your local GitLab server. Also, we need access to a Kubernetes cluster. If you have a cloud account on one of the public cloud providers like AWS, Google Cloud, OCI, and so on, you can bring up a cluster and use that. And maybe these public clouds charge you. Also, there are another choice to bring up a Kubernetes cluster on your local machine. If you are using Windows or Mac machine, you can install and configure Launcher Desktop on your computer. Really, I have recorded a video about how to install and configure Launcher Desktop on Windows machine, and I pinned its link above this video, and by click on it, you can access to it and configure Launcher Desktop on your computer. If you are using Linux Ubuntu distribution or Windows sub Linux, you can use Multipass package to bring up quickly a Kubernetes cluster on your local machine. So these two steps are mandatory to run the labs of this presentation. In continue, we have to create two repositories on GitLab server, and we are using one of them to make a connection or make a tunnel to Kubernetes cluster, and the other one will keep our project data. Here is the summary that we will do on this presentation. For this presentation, I'm using gitlab.com. I connect to my account on GitLab and create two repositories there. During the creation, I will describe you why we need to repository. Okay, here is my GitLab account. So create new project, create blank project, and give it a name. For example, K8S connection. The reason for create this repository is to make a connection between GitLab and Kubernetes. For that reason, I selected K8S-connection. You can use every name that you want. So change it to public. Also, you can make it private. It's depend to you. For here, I'm selecting public and create project. Also, back to the first page and create another project. Let's back to diagram. Here, I'm going to build repository A, and in this repo, we will keep our data. It means all the codes that I prepared for my project, I will upload here. So let's back to GitLab again and make it K8S, for example, data. Also public and create project. Let's go into Google. I search for integrate Kubernetes cluster with GitLab. From the first result, you see a document that is written connecting a Kubernetes cluster with GitLab. If you read it here, to connect a Kubernetes cluster to GitLab, you must first install an agent in your cluster. So click here, installing the agent for Kubernetes. Prerequisite: before you can install the agent in your cluster, you need an existing Kubernetes cluster. As I told you in prerequisite some minutes ago, access to Kubernetes cluster is mandatory. Also, I mentioned if you don't have access to any public cloud provider, you can bring up a local one on your personal computer or your laptop. Here is my personal computer and I'm using Windows. So I installed WSL on my computer and also installed Launcher Desktop. So if you install Launcher Desktop on your computer, automatically you have a Kubernetes cluster. For testing, just type kubectl get nodes and you see the Kubernetes cluster with one node is up and ready to use. So back to document on GitLab. So an existing Kubernetes cluster is ready. So going down, installation steps. To install the agent in your cluster, create an agent configuration file. In the first step, we have to create an agent configuration. To create an agent configuration file, choose a name for your agent. You have here it's mentioned the name must be unique in the project, contains at least 63 characters and so on. Okay, let's see in continue. In the repository, in the default branch, create an agent configuration file at the root. Let's copy this one, back to GitLab. In the Kubernetes connection repository that we have created for connection between GitLab and Kubernetes, here it's the root and just click here, new file, and put it here. Here for agent name, we have to select a name. So let's select K8S connection. And at the moment, no need to write inside this file and just commit change. You see, we have a config YAML file, and at the moment, we don't have any configuration inside this. Here, it's like a firewall. And in this file, we define which group, which username, which repository can access to Kubernetes cluster. So in next some minutes, I will completely explain what configuration we should define here. Let's back to roots. You see here, we have created a file with this path here. Back to documentation. Here it is mentioned you can leave the file blank for now and configure it later. The next step is to register the agent with GitLab. We have to register that in GitLab at first. How we do that? You must register an agent before you can install the agent in your cluster. To register an agent, we have go to operate Kubernetes cluster. Let's back to GitLab account. From the right side, going down to operate Kubernetes cluster. You see it's empty and we don't have any connection to cluster. Connect a cluster. Just click here, open, and you see the name we have created some seconds ago. Click on it and register. Here give you configuration, and it is mentioned you have to keep this configuration in a safe place, because if you close this page, you will lose this configuration. Agent access token. You can copy this token and use in Kubernetes cluster to make a connection with your GitLab, or you can use Helm. So I'm using this section, but let's copy this one and keep it in a safe place. Let's back to terminal in Kubernetes cluster and run this configuration. Copy the first one and in terminal. Also here, when you bring up a cluster by Rancher desktop, Helm package is also installed. So check Helm. Yeah, it is installed. So it's already exists here. Helm repo update. Okay, update is complete, and copy the last one and enter. You see, thank you for installing. Your release is named KAS connection. Let's back to our repository on GitLab. Let's close this one. We don't need it anymore. Let's refresh. See, it is connected. So the first step successfully done, and the tunnel between GitLab and Kubernetes cluster is up. In the next step, let's copy our project data to second repository. So let's back to other repository. As you remember, its name was K8s-data. So at the moment it's empty. Let's clone it back in terminal and just type git clone and the address ls. Let's switch inside that. You see it's empty. Git status, and you see it's up to date. What data we need to push on repository? At first, I need to project resource that I designed by HTML, and it is located here in src ls src. You see CSS file, HTML, and so on. So to use this project as a container, we need to build an image. As you know, for build an image, we need a Docker file. Here, I created a Docker file, just cat Docker file. Let's clean and open it again. You see, inside Docker file, I'm using Nginx as a base image. To show you quickly, let's bring up an Nginx server by docker run -d -name web001 -p connect port 8082 from my computer to port 80 in the Docker and the image Nginx. Let's browse it by my browser. Local host port 8082. You see, welcome to Nginx. So I'm gonna use Nginx as a base image to build an image for my project. Let's back to terminal and let's stop this container. Done, and let's remove it. Oh, let's clear the screen. So in my Docker file, as you see here, I'm using Nginx. In the second line, I wrote, hey Docker, please copy my resources from the src folder and paste them in Nginx in this path, /user/share/nginx/html. Let's test it manually, and everything going well. We will use this instruction in GitLab cicd to automatically build an image for us. Let's continue. How to build an image manually? Just type docker build -t. It means add a name and tag to new image that you are going to build. So I'm gonna name it sample and tag it with the version 1, and at the end, where is my Docker file is located, just type dot. It means is located in the root. So just enter. You see this image with this tag is built. Just type docker image ls grep sample. You see in the first line, sample version 1 40 seconds ago was built. So far, so good. Let's use this image and see if everything is correct. So docker run in a state of Nginx, let's using sample version 1. Docker container is built, so let's browse it. Here, if I refresh, you see it's my project. So at the moment, we see how to build an image manually and how it works. Let's back to terminal and stop this one and remove. Nice. The next step is how to push this image to a repository that we can use in Kubernetes cluster. Normally there is Docker Hub and we can use Docker Hub to push our image there. But we don't want to use it because normally every company has its private container registry. So here we're gonna use GitLab container registry as a private registry for our project. Let's back to GitLab, going to left side, and in deploy section you see container registry. At the moment it's empty and we have to push our built image here. At first I show you how to do it manually, and in next minutes you will see how to do it automatically in cicd. If I going down, you see at first we need to log in GitLab registry. So let's copy this one and back to terminal. Already my credentials exist on my computer and successfully log in to GitLab. But if you are first time login like that, it will ask you username and password. So in first step, we are connected in registry gitlab.com through CLI. Let's see next step. In next step, it shows us how to build an image. Back to terminal, and let's add sample v1. Image built, just Docker images. You see here, it is built. Let's go in here and show us how to push it to repository. Copy and just sample version 1. You see here, it's going to push the image to the GitLab registry. Here you are. It is pushed to GitLab container registry. Let's check it and refresh this page. You see, it is here. So, how we do these steps automatically by cicd. We don't want this image anymore because we need to push it here automatically. Let's delete it. Delete. Done. Let's back to terminal and copy the project data to the repository. You see, I did copy them in the repository. Let's git status, git add, git commit -am, add project committed, and git push. They are pushed. Let's go in and check repository quickly. You see this folder and Docker file copied here. For cicd, as I described in one of my video how to start with GitLab cicd, we need create a file called .gitlab-ci.yml. If you don't know how to start with GitLab cicd and how it works, I suggested to watch my video about this, and I have pinned it above of this video. So here we need to define job and steps. Now, how we configure this file? Let's back to Mr. Google, and in Google just type GitLab container registry cicd, and from the result click here and see the proper document for this step. Here, build and push container images to the container registry. Here, this step that we did manually. So we need this section, configure your .gitlab-ci.yaml file. Let's going down. There is some example. Just we need this example, container registry example with GitLab cicd. Just copy this one and paste it in the file that we have created on GitLab. Let's back, paste it here. Let's make it more cleaner. Define stages. We define which stage we need to use. So we name it build stage. You can name it everything you want, but for user-friendly, I use build. Here is the name of our job. Change it to image, build image. Which image we're gonna use to run on GitLab runner? We're gonna use the Docker image. Which stage we are using? This stage, build. Which services? Docker. Let's remove this one. Docker in Docker services. What it means? GitLab runner is Docker container, and we're gonna run another container image inside that container. So it's called Docker in Docker container. So in a script section, there are three commands. You remember them. The first one is for logging to GitLab registry. The second one for build image, and the third one for push image to GitLab registry. So for the first one, docker login -u username. There are some built-in variables inside GitLab. Let's make it more clear. Let's copy this one. Which username we gonna use to connect GitLab repository? My username here, my username is, and which password? I gonna type my password, and also the GitLab registry address. Instead of writing all the credential in text here, it is better to using built-in variables from GitLab. So let's remove this one. For the username, there is a variable CI registry user. Automatically, GitLab determine this one because you are logging in your repository. For the password, also GitLab has your password, and no need to define here, just using this variable. And which server, if using this variable CI registry, automatically GitLab will determine it means registry.gitlab.com. It's done this. The first line done. The second one, docker build CI registry. When using CI registry, as you see also it here, it means registry.gitlab.com. Let's back to terminal and show you something. Remember this command? registry.gitlab.com. Here it's related to my account in GitLab, the name of the repository, and the name of image we're gonna make it. So let's copy this one. Just let's copy it here. The first section will return this one, registry.gitlab.com. So let's remove this one. The other section should be copy and paste it here. So when this line runs, it will create an image with this name for us. And in the third line, it will push that image. Let's copy this one. Where? To GitLab registry. Here also we can add an echo message, image built. Let's save it. As soon as we save it, it will go and run, and it will build an image and push it to GitLab repository. Let's add a message by cicd and commit change. This file has been successfully created. Let's back to section pipelines, and here it show you it is running. Let's click it here. Build image. You see here it using Docker executor with image Docker. You see image built. Let's check it. What it happened? Run Docker file, create an image, and then push that image to GitLab repository, and job succeed. Let's go into left side and check deploy container registry and see here the image added here. If I click it here, you see 1 minute ago it was pushed here. So we could build an image and push it to GitLab container registry by cicd. The only remaining part is Kubernetes section. In Kubernetes cluster, how we can use this image, the image that we pushed it in GitLab container registry. So how we can use that? For answer to this question and to find out how to bring up a container inside Kubernetes cluster, it is better to give you a perspective of Kubernetes cluster. Here we assume this is one node of our Kubernetes cluster and it's the IP address of this node. Here we're gonna to bring up a container with the build image here. For bring up a container, there is a concept in Kubernetes, it's called pod. Pod is the smallest component in Kubernetes. Assume pod is like a box and we bring up our container inside the pod. Normally in Kubernetes, we never use the name of container and we use the name of pod. In each pod, we bring up a container, but sometimes we can bring up multi-container for some specific purpose. But at the moment, we assume in each pod only there is one container. So for bring up our application, we need to bring up a container inside the pod with using the image that is container registry. So let's bring up a pod here, and this is our pod. We name it app with using the sample version 1 image. When we bring up a container or a pod here, it gets an IP from the Kubernetes cluster. So our application now is up, and how we can access to this application. Here there is a user and want to access this application. How can do that? Is it possible to use this IP in browser and access it? The answer is no. Let's clean these lines because the pod is alone inside the cluster and only is accessible from inside the cluster, no from the external. And also, if for any reason the pod restarted, its IP will be changed. It means the pod never keeps a permanent IP. For solving this problem, another concept to play and called services. The service is a logical component and its IP is permanent and never change, and we put service in front of the pod. So for access to application here, we have to access this IP address through service. We have some different type of services. By default, it's called cluster IP type. And from its name, you can see it is accessible only inside the cluster. For example, you have some application inside the cluster and they want to communicate with each other. So only they can communicate through cluster IP service. So still our issue exists. How we can overcome our issue? We want to access it from the external. How we can do that? There is another type of services. Before going forward, this port called port and this port called target port. It is important in configuration. So for access from outside, there is Another type of service is called node port. When bring up a node port services, the service will attach a port to the cluster node that will be one by one mapping between service and that port. The problem solved, and from the external, just we type the IP address of the node, and using the node port, we can access to application. So far, so good. But still, there is one thing that I need to mention it. When bring up an application here, need to pull image GitLab container registry. But as I told you before, for access to container registry, we need username and password. So in the configuration, if using them in clear text, it's not a good way. So what we can do, there is another concept inside Kubernetes cluster. It's called secret. We can define a secret and put the credential inside the secret and call it inside the pod configuration. So we need three manifests. One manifest to bring up a pod, one for secret to keep credential, and one service which type node port to allow us access application from outside. Let's do it manually, and after that we will add them in cicd. How to create this manifest quickly by CLI. For create a pod by CLI, just we need to type kubectl, run, and give it a name for your pod. For example, login application, and the image name, -- image, from which image this pod will be created. So let's back to gitlab.com. Inside the repository, from the left side through deploy container registry, you see the image we're gonna use. Just click here and copy here. Which tag or which version we're gonna use, just click here and you see version 1. Let's back to terminal and paste it here and type version 1. If I press enter here, it going and will create a pod with login-app name for us. For prevent creation at this time, just at the end type --dry-run equal client -oyamo. It will run on fly and not create on Kubernetes cluster. Let's enter. You see a manifest will be created. So for having this one inside the file, just at the end type this one, call it pod.yamo. As you know, all the manifests in Kubernetes are based off YAML language. Enter and just swim pod.yaml. Here you are. All the configuration you need here. Some parameters are here. At the moment we don't need them. One of them is this one. Just remove this one. And another one is resources, and also DNS policy and a status. It's done. But one important note: when this pod is going to pull this image, need what? Credentials. So Here we have to add from where can get the credentials. Leave it as is, save it, and let's go in and create a secret. And after that, we will define this secret inside the pod. For create a secret, just type kubectl create secret. Let's enter. You see here, there are some types of secret. One type is Docker registry. You see here, create a secret for use with a Docker registry. When you're gonna pull image from each registry, Docker Hub registry, GitLab registry, and so on, we have to use this type. So, secret Docker registry -- help. A lot of information are here. Just let going up. There are some example here. You see here, kubectl create secret Docker registry. You have to give it a name, and after that, Docker server. The name of the server here is registry.gitlab.com. Docker username, your username, and Docker password. So let's copy from here to here and clean here, back here, and paste it here. Sorry, let's clean. Let's, for the secret, change it to app secret, and Docker server, we have to change it to registry.gitlab.com, and from the help -- username, my username, and -- password. Here -- Docker password, and put my password here, and at the end we add -- run equal client -o YAML, and save it, for example, to secret.yaml. Enter, and a file with name secret is created. Let's open it. Vim secret.yaml. You see the username and password and address of GitLab registry are hash here. Let's delete this line. We don't need it anymore. Just save it, and it's done. Here, let's bring up the secret. For bring up the secret, kubectl apply -f secret YAML. Enter. You see secret created. To see the list of secret on Kubernetes cluster, just type kubectl get secret. Enter. You see app secret is here 40 seconds ago. So let's take this name app-secret and add it in pod configuration. Let's open pod configuration, and we have to add it here. How? If you search on internet, you will see this parameter. Let's save it and copy this one and back here and paste it here. It's done. Just save it, and let's bring up the pod here. Just type kubectl apply -f and pod name. Done. Kubectl get pod. You see, login application is in running status. So far, so good. So the last step is to create a manifest for service. Just type kubectl create service, or we can use an abbreviation svc --help. You see there are different type of service that we spoke about them. We have to use node port. So let's remove this one, add this one, and again type --help. You see there are some information here. Let's use this example. After node port, we have to name it. For example, login-svc. And after that, you see --tcp --tcp. Which port we have to add it here? Let's see in presentation. The port and target port 80 for the service and 80 as target port. --dry-run equal client -o YAML. Let's bring it here and enter. You see, this is the service one. Let's record it in a file, login svc.yaml and vim login svc.yaml like before, and we can change this name like this one, and you see the type is node port here. The important section is here, selector. In the selector, we define the label of pod. When we define it here, when we run service, it will go and find pod and will attach it to itself. Let's close from here and open pod. You see the label is this one. Copy this one back to svc and in selector paste it here, and let's delete this one. So when we run this service, it will go and find a pod with this label. Let's save it. Another thing is here, when we bring this service up, which port in cluster node will be assigned for this service. In Kubernetes documentation mentioned, it will assign a port between 30,000 to 32,767. If we don't define a port here, it will automatically take a port from this range. Also, we can define it manually. Let's leave it as is and see what port will assign to this service. Save it and let's run this service. kubectl apply-f login svc and enter. You see service created. With this command kubectl get svc, you will see the list of services. You see the cluster node assign this port to service. If we wanted to be sure the pod is under the management of this service, just type kubectl describe svc, the name of this service, and here you see all the information related to this node port service. If we check endpoint, you see there is an IP here. It's belong to pod, and from where we can be sure this is the IP of the pod, just type kubectl get pod-o wide. You see login application, its IP, and this is here. So At the moment, we are sure the service is running and manage this pod. So let's type kubectl get node -oy, take the IP of the node and put it in browser. And which port? You see this port. Enter. Here you are. The application is running inside Kubernetes cluster. So far, so good. I'm going to stop service and delete the pod that we have created manually, and we will use cicd to create them. I have deleted pod, secret, and service. Let's go in and use cicd. Before using cicd, I have to upload this created manifest to GitLab repository. You see, I did copy the file here in this folder and git status here, git add git commit -am and push them. Done. Let's back to GitLab repo. You see, K8s file are here. Now it's the time to add configuration in GitLab CI YAML. Going to build pipeline editor and add another stage here, deploy. So let's go into GitLab documentation and find the proper configuration for deploy stage. In Google, search using GitLab CI/CD with a Kubernetes cluster, and from the result, click here and you see a good document how to using GitLab with Kubernetes. So let's going down, and here you see an example. Just copy this one and paste in configuration on GitLab repository. Paste it here. Just change job's name as deploy project, and which stage we should use, deploy, and here an image that we'll use on GitLab runner. Let's remove this one, we don't need it anymore. Here kubeconfig, use context, path to agent repository. If you remember, at the start of this presentation, we have created an agent in another repository. Let's go into that repository. Here is the repo. From the left side, in operate, Kubernetes cluster, and here is the name of agent. Just copy this one, back to our configuration, agent name. Each path, this is the path. Also, to make it more clear, it is better to define variables here, and in variables define this variable the same as I put it here, and in a state of using this one, just copy this and paste it here with $sign at the first of it. So at first it will find this permission to have access to our Kubernetes cluster. If the connection is okay, with this command kubectl get pod, it will show us a list of pods that exist on Kubernetes cluster. At the moment, still I didn't define any command for our manifest. Let's test and see if everything is okay, but let's add another command here, kubectl get nodes -o. Okay, let's save it and see if it works or no. Let's click here and see the job. The first step is done. Yes, it's for image building. The important section is the second one. As see, it is failed. You see, no context exists. Do you know why? Let's back to presentation. At the moment, cicd config file is here, but another repository is connected to Kubernetes cluster. Here, we have to authorize repository A to make a connection to Kubernetes. Let's back to GitLab, Kubernetes connection. If you remember, we have added a file here, config YAML. There is no configuration here. If you remember from the starting of this presentation, I told you this config file works like a firewall. And here we have to make a permission which repository has permission to access Kubernetes cluster, which user has permission, which group has permission. Here we have to define which one has permission. So here we need to add configuration. Edit. Let's back to documentation. Here, authorize agent to access projects in your group. Also here, authorize the agent to access your project. Let's copy this one, copy, back to configuration, and paste it here. CI access, which project? The name of the other repository. Let's go into other repository, data, and it's the name of this repository. Copy, back here. So let's save it back to K8s data, the repository that our data is there, and going to build section, pipeline, and rerun the job again. It's running, back here, going here, again failed. Let's see what's the error. No context exists with name. This one. Oh, it seems I made a mistake. Let's back to CI/CD configuration. Here you see here I have to correct this one. Edit. At first it should be this one because our agent is here, and the name of agent also I have to remove this one because we defined it in variable. Let's save it. You see, this time successfully finished. Let's go inside that, and you see it is connected there. You see here kubectl get pods. Yeah, this web application is running, and nodes also. You see here the name of the node and the IP of that. Good. Let's add our real configuration there. Back here and edit this one. Paste the commands here. The first one, it shows us a message, deployment login application to Kubernetes. The second line lists the file inside this folder in the root directory. This variable retrieves the root address. Back here, it means here K8s files. Back here, K8s files. And the next line, apply all the file in this directory to Kubernetes cluster. Here there are 3 YAML files, one for pod, one for secret, and another one for service. And finally, it will show us the list of pods and services. Let's commit. Based on this CI/CD, we have 2 stages. The first one will build an image for us, and second one will deploy this image on Kubernetes cluster, and there will bring up 3 components: a pod, a secret, and a service. Let's see here. Deploy job is running. Here it show us job succeed. Let's see. At first show us a message, deployment login application to Kubernetes. Here show us the list of manifest, service, pod, and secret created. And get pod, you see login application container creating, and also show us the login SVC is created there with this port. And from here also find the IP address of the node. Copy, going to browser, and also take the port, paste it here, and enter. Done. So by cicd, we could build an image, push it to container registry, and then in deploy section, and then deploy our application on Kubernetes cluster using the image that was on GitLab container registry. I hope you like this presentation, and if you like it, don't forget to subscribe, and also I will appreciate if you comment your feedback. Thank you so much.